When we look into the endless expanse of the night sky and ponder the profound possibility of life existing beyond Earth, our imaginations have historically drifted toward our nearest planetary neighbor, Mars. We picture its vast red plains where ancient rivers might have once flowed billions of years ago. We romanticize the search for microscopic fossilized remnants of primitive bacteria buried deep beneath the arid, rust-colored soil. Mars has always been the primary focus of our search for extraterrestrial biology. But as our understanding of the universe has deepened, we have begun to realize that perhaps we have been looking in the wrong direction. The most promising place to find living, breathing extraterrestrial ecosystems in our solar system is not a barren, rocky desert bathed in faint sunlight. Instead, it might be a frozen, highly irradiated moon, located hundreds of millions of miles further into the deep dark of space. A place where the surface temperature routinely plunges to a bone-chilling minus 260 degrees Fahrenheit. A place known as Europa. Europa is one of Jupiter's dozens of moons, slightly smaller than Earth's own moon. To the untrained eye, looking at it through a standard telescope, it appears completely dead and utterly hostile. It looks to be nothing more than a giant, frozen ball of solid ice wandering aimlessly through the cold outer reaches of our solar system. Its environment is relentlessly bombarded by intense, deadly radiation generated by Jupiter's powerful magnetic field. If an astronaut were to stand on its surface without heavy shielding, that radiation would prove absolutely lethal in a matter of mere minutes. Furthermore, there is essentially no atmosphere to breathe, absolutely no sunlight warm enough to thaw the frozen surface ice, and no visible signs of biological activity. At first glance, it is a wasteland. But Europa is a world of astonishing deception. It is a compelling story of hidden potential, where the true marvels are securely locked away from the destructive realities of space. Beneath that formidable, miles-thick crust of solid, unyielding water ice lies a magnificent secret that has captivated the minds of astronomers, planetary geologists, and astrobiologists for decades. Because under that impenetrable frozen shell, hidden in total darkness, lies a vast, global liquid water ocean. This is not just a small underground lake, nor is it a localized pocket of slushy ice. This is a massive, incredibly deep globe-spanning ocean of salty liquid water that wraps around the entire moon. In fact, scientists conservatively estimate that this single, relatively small moon contains approximately twice as much liquid water as all of the oceans, lakes, and rivers on Earth combined. Take a moment to let that staggering realization sink in. A moon smaller than our own possesses a reservoir of water that utterly dwarfs the total water content of our entire blue planet. And in the world of astrobiology, there is one universal, indisputable rule. Where there is liquid water, there is always the potential for life. The remarkable story of Europa's discovery begins more than 4 long centuries ago, specifically in the momentous year of 1610. The brilliant Italian astronomer Galileo Galilei, utilizing a newly invented optical tool called a telescope, decided to turn his gaze toward the largest planet in the sky, Jupiter. Through his crude glass lenses, he observed something that no human had ever seen before: 4 tiny, distinct points of light hovering closely around the giant planet. He carefully tracked their movements night after night, diligently recording their shifting positions, and eventually came to a shocking realization. These were not distant stars lingering in the background, but actual physical objects orbiting Jupiter itself. This was a revolutionary discovery, one that fundamentally challenged the prevailing cosmological belief of the era, the idea that everything in the heavens revolves strictly around the Earth. These 4 celestial objects soon became known as the Galilean moons: Io, Europa, Ganymede, and Callisto. Around the same time, the German astronomer Simon Marius independently observed these very same moons and is credited with giving them their names. For hundreds of years following this initial discovery, Europa remained little more than a blurry, intriguing speck of light in the eyepieces of increasingly powerful terrestrial telescopes. It wasn't until the dawn of the space age, when humanity finally began sending complex robotic emissaries out into the cold depths of the outer solar system, that Europa's true nature slowly began to reveal itself. When the groundbreaking Voyager spacecraft flew past the Jupiter system in the late 1970s, the detailed images they beamed back shocked the global scientific community. Unlike our own moon, which is heavily and violently pockmarked with thousands of impact craters from billions of years of relentless asteroid strikes, Europa was incredibly, almost unnervingly smooth. In fact, planetary geologists consider it to be the smoothest solid object in the entire solar system. Its entire surface is essentially a colossal, planetary-scale glacier composed of almost pure water ice. This pristine ice gives Europa an incredibly high albedo, meaning it acts much like a giant mirror, reflecting a massive amount of the faint, distant sunlight that manages to reach it. But the most critical and revealing clue was that lack of craters. In the field of planetary science, interpreting a surface is like reading a history book. A heavily cratered surface indicates a very old, geologically dead world that has remained undisturbed for eons. Conversely, a smooth, unblemished surface means that something active and powerful is continuously erasing those craters. By counting the few craters that do exist, scientists concluded that Europa possesses a remarkably young surface, estimated to be anywhere between 20 to 180 million years old. On a cosmic timescale, that is merely the blink of an eye. The most prominent features on this smooth, icy expanse are the long, dark, linear fractures known to scientists as lineae. These dramatic streaks crisscross the entire globe in a seemingly chaotic web, making Europa look somewhat like a cracked marble. But what massive forces could possibly cause miles of solid ice to crack so violently, and what exactly is actively resurfacing this frozen, distant world? The answer to this mystery lies in the immense gravitational power of its parent planet, Jupiter. Europa orbits Jupiter at a relatively close distance, completing a full orbit every 3.5 Earth days. However, its orbit is not perfectly circular. It is slightly elliptical or oval-shaped, due to the gravitational tug-of-war it plays with its neighboring moons, Io and Ganymede. This means that during some parts of its orbit, Europa is pulled much closer to Jupiter, and during other parts, it swings farther away. As this orbital distance constantly changes, the gravitational pull from Jupiter dramatically fluctuates. When Europa is closer, Jupiter's massive gravity pulls on the Moon with incredible force, literally stretching its solid rocky body out of shape. When Europa swings farther away, the gravitational grip relaxes slightly, and the Moon settles back into a more spherical shape. This constant, powerful stretching and squeezing happens continuously, day in and day out. To understand this, imagine taking a thick metal paperclip and rapidly bending it back and forth in your hands. If you touch the bend, you will feel the metal quickly become very hot. This is precisely the physical process that is happening to the entire interior of Europa. This remarkable process is scientifically known as tidal heating. The continuous friction generated by the Moon's internal rock and ice violently shifting and grinding against itself produces a truly tremendous amount of internal heat. This heat constantly radiates outward from the Moon's deep rocky core, steadily warming the underside of the thick outer ice shell. It is this vital, continuous tidal heating that provides the crucial, life-sustaining energy needed to melt the ice and maintain the deep, global liquid water ocean. Without Jupiter's massive gravity relentlessly kneading it, Europa would be frozen completely solid all the way down to its core. But because of this endless gravitational dance, Europa manages to maintain a warm, active, and highly dynamic interior environment. This powerful tidal flexing also perfectly explains the strange dark linea on the surface. As the Moon bulges and flexes, the brittle outer ice shell is subjected to immense structural stress, causing it to violently fracture and crack open. Warmer, slushy ice from the lower crust, or perhaps even liquid water welling up directly from the deep ocean below, can force its way into these cracks. When this relatively warm material reaches the incredibly cold surface, it freezes almost instantly, creating the distinct raised ridges and the reddish-brown streaks that define Europa's unique appearance. The confirmed existence of this vast, dynamic subsurface ocean is exactly what places Europa at the very top of the list for potential extraterrestrial life in our solar system. Astrobiologists generally agree that life, as we currently understand it, absolutely requires three fundamental, non-negotiable ingredients to exist. The very first ingredient is a reliable solvent, a fluid medium in which complex chemical reactions can easily occur. For all known life on Earth, that vital solvent is liquid water. Europa has this requirement covered in absolute abundance, offering a stable ocean that is both global and incredibly deep, and crucially, an ocean that is likely in direct ongoing contact with a rocky, geologically active seafloor. The second necessary ingredient is the right chemistry. Specifically, life requires essential elemental building blocks like carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. While we cannot yet send a submarine to sample Europa's ocean directly, planetary scientists strongly believe that these crucial elements were likely present when Europa originally formed. Furthermore, the ongoing chemical interaction between the salty liquid water and the active rocky seafloor is absolutely critical for freeing up these elements. This brings us to a truly fascinating and profound possibility: the existence of hydrothermal vents. Here on Earth, at the very bottom of our deepest, darkest oceans, completely isolated and far beyond the reach of any sunlight, we find towering chimneys of rock spewing superheated, highly toxic, mineral-rich water into the freezing depths. These hydrothermal vents are formed when cold seawater seeps deep into the Earth's crust, becomes superheated by underlying magma, and is violently expelled back up into the ocean. When these deep-sea vents were first discovered on Earth by oceanographers in the late 1970s, they utterly revolutionized our understanding of biology. Before their discovery, it was a universally accepted scientific fact that all life on Earth fundamentally relied on energy derived from the sun, through the familiar process of photosynthesis. But around these dark, superheated vents, scientists found thriving ecosystems living in utter permanent darkness. The microscopic bacteria found here do not use sunlight at all. Instead, they utilize a process called chemosynthesis, extracting their biological energy directly from the toxic chemicals and minerals in the scalding vent fluids. These bacteria form the base of a bizarre food web that supports giant tubeworms, massive clams, and blind crabs in an extreme environment that was previously thought to be completely barren and inhospitable to life. If similar hydrothermal vents exist on the rocky seafloor of Europa, and the immense tidal heating strongly suggests that they could readily provide the necessary chemical nutrients and the absolute critical third ingredient for life: a steady, reliable energy source. In the dark, isolated, high-pressure ocean of Europa, sunlight simply cannot penetrate the miles-thick ice shell. Photosynthesis is a physical impossibility. Therefore, any life existing down there would have to rely entirely on chemical energy. However, the scientific picture is never perfectly clear, and significant mysteries still remain. According to recent scientific updates as of 2026, researchers are intensely investigating the complex, poorly understood mechanics of Europa's ice shell. Some of these newer models suggest that the icy crust might actually be a much stronger, much thicker, and far more formidable physical barrier than scientists had previously hoped. If the ice shell is extremely thick and rigid, it makes the crucial transfer of materials between the irradiated surface and the deep ocean much more difficult. It raises serious questions about exactly how much of the vital chemistry from the surface, such as complex organic compounds delivered by ancient comet impacts, or vital oxygen generated by Jupiter's radiation-splitting water molecules, can actually make its downward journey through the ice and into the dark waters below. Without a reliable supply of surface oxidants, the ocean might not have enough chemical energy to support complex life. Despite these significant challenges and uncertainties, the underlying potential habitability of Europa remains a profoundly strong, scientifically compelling possibility. The sheer volume of liquid water, the persistent and powerful internal heat source, and the highly likely presence of an active rocky seafloor create an environment that practically demands intense, immediate investigation. We desperately need to look closer. We need to find a way to see beneath the ice. This intense curiosity is the primary driving force behind the upcoming NASA Europa Clipper mission. Scheduled to arrive in the Jupiter system in the year 2030, the Clipper spacecraft is explicitly designed to conduct the most detailed, comprehensive, and technologically advanced exploration of Europa ever attempted by humanity. It is crucial to understand that the Europa Clipper is not a lander. It will not touch down on the dangerous icy surface, and it is certainly not a robotic submarine designed to melt its way through miles of ice into the ocean below. The radiation environment surrounding Europa is simply too intense and too destructive for any modern spacecraft to survive in a permanent orbit around the Moon for very long. Its electronics would be fried in a matter of weeks. Instead, the brilliant engineers behind Clipper have designed a clever mission profile. The spacecraft will enter a wide, highly elliptical orbit around Jupiter itself. From there, it will perform dozens of extremely fast, incredibly close flybys of Europa over the course of several years. It will dip into the deadly high radiation zone just long enough to frantically gather critical, high-resolution data before swinging back out into the safety of deep space. During these daring, high-speed flybys, the spacecraft will employ a highly sophisticated suite of scientific instruments to eagerly peer into Europa's deepest secrets. It will use powerful ice-penetrating radar to essentially see directly through the frozen crust. This will allow scientists to finally determine the exact thickness of the shell and excitedly search for massive subsurface lakes or shallow channels of liquid water that might exist trapped much closer to the surface. It will carry incredibly high-resolution cameras to meticulously map the intricate web of lineae and search for any telltale signs of recent or ongoing geological activity, such as massive water vapor plumes erupting out into space. It will also use advanced spectrometers to precisely analyze the chemical composition of the dark, mysterious material filling the cracks on the surface, finally giving us our best clues yet about the exact chemistry of the dark ocean hiding below. The Europa Clipper mission truly represents a monumental, historic leap in our ongoing quest to understand habitability in the cold, distant outer solar system. While it is important to temper expectations by noting that it is not explicitly designed to find living biological organisms, it will determine, definitively and once and for all, if Europa truly possesses all the necessary fundamental ingredients to support life as we know it. Europa fundamentally challenges our terrestrial biases. It forces us to drastically redefine the boundaries of where life might exist in the universe. It teaches us an incredible lesson, that habitability does not necessarily require a balmy, sun-drenched surface or a thick, breathable atmosphere. Instead, the cradle of life can perhaps be found in the cold, incredibly dark, and highly pressurized depths of an alien subterranean sea, sustained entirely by the relentless gravitational heartbeat of a giant planet. We do not yet know if there is actually life swimming or drifting in the dark alien waters of Europa. We simply do not know if primitive microbial ecosystems are desperately clinging to the warmth of deep-sea hydrothermal vents, living out their entire existence completely unaware of the massive icy ceiling miles above them. But the very fact that the conditions for life might perfectly exist there, on a small, cracked moon that looks entirely dead and frozen on the outside, makes it undeniably one of the most thrilling, tantalizing, and fundamentally important destinations in the history of human space exploration. Beneath that formidable ice, Europa is silently waiting to share its ancient secrets. And very soon, with the arrival of the Europa Clipper, we will finally be listening.
If you enjoy this content and want to see more, please consider subscribing. A quick tap on the like button also helps us learn what topics you like best. Thank you for watching this video, and see you in the next one.